I have good morning, guys. So let's start the another concept called Kubernetes, and we'll just go through one the difference between the Docker and Kubernetes, the drawbacks of Docker. So so if you look at this image, Docker has some limitations. It is a tool that is used to automate the deployments of the application in lightweight containers. Apps are deployed in the forms of services. Docker does not support the auto scaling. Auto scaling, in the sense, let us take if you are developing one application or one software, it should support the application in all the all the time when the user hits more traffic. So that time also it's supposed to support when the hits goes down also it should support. And like if your resource is consuming more memory, that time also it needs to spin up multiple containers. So that is called auto scaling. It should has auto healing on the features, and it doesn't support the high availability, and it doesn't support the more security point of view. And um, like the so many disadvantages are there in the Docker container, but the concept is remains same. Only thing, the the Kubernetes is using the same concept, underlying the concept, Docker concept only, but it has come up with a lot of features. It is going to support the auto scaling. It is going to support the horizontal scaling, vertical scaling, and also it is going to support the multi-container feature as well. So many advantages are there compared to the Docker. And again, Kubernetes, it is one of the orchestration tool for the containerization, but there are multiple flavors are there, like Amazon Kubernetes services, AWS, Amazon Kubernetes EKS, I think, yeah. And Azure Kubernetes service is there, AKS, Azure Kubernetes service, and Google also has their own Kubernetes services, GKS, Google Kubernetes services. So like that, but the concept remains the same, only the providers are different. So that's how the advantages and disadvantages of the Docker, over to the Kubernetes. So if you look at the architecture of the uh, Kubernetes, if you notice this one, the main component is the control plane, where it resides on the master node. And if you look at the node 1, node 2, these are all the different VMs. Only it is gonna spread their uh, parts or containers loading onto the target nodes. So I mean, we will get to know this in the while doing the hands-on part. But just look at the components. So the control plane has the cloud controller manager, and it has a Kube API server, etcd it has, and also the scheduler, control manager it has. Okay, so these are all the main components which are reside on the master controller. And there are a couple of few components are which resides on the nodes, or the target nodes, I would say. So kubelet is the one of the node which resides on the target machine or node, worker node, or I would say worker node also. Both are same, VM or worker node or target machine, all are same. This just like similar names, right? So the kubelet is one of the agent which resides on the target nodes, and which is able to maintain the consistency of the each pod and containers on the target nodes. And the kube proxy is again it's a network proxy. When I say network proxy, the each the communication, from the pod to pod, or from master node to worker node, this communication part is going to take care by the queue proxy. So each node is having a multiple pods. So if you look at this image, part 1, part 2, part 3, so these are all the parts again. It's a smaller unit in the cluster, no, in the clusters. But each pod is having a multiple containers as well. So what earlier in the Docker, we used to create only one container at a time, but it is not possible to create a multi-container concept uh, in the target nodes. But again, in the pod itself, we can create a multiple containers and across the different nodes also. So if you look at one pod here and one more pod is creating here, so like that, how many target nodes you are creating, based on that, it is gonna schedule the um, uh, I mean scheduling going to schedule the control plane with the help of there is a scheduler component is available in the cluster end. Okay, so like this, and this is cloud provider API is again a, so if you wanted to communicate to the cluster, there should be some CLI part, right, in order to communicate the, your master node as well as the pods. So whatever the information you are going to fetch, you are communicating through the through the API that is called cloud provider API. Okay. Um let's go to the next one. Okay, so if you look at the components, these are the brief brief about each the components. If you look at the Kube API server, it exposes the Kubernetes API, and it is like a in, initial gateway to the your cluster, and it listens the whatever the queries come from the user or through the CLI, and using the kubelet is the commandlet, which is standard way of communicating to each cluster. So we will get to know in the while doing the practical session, so how this kubelet works. So just know the terminology of each component and what is the purpose of each component. Okay, cube scheduler, as I said, no, this cube scheduler is going to when somebody wanted to create a one pod, so this cube scheduler is going to schedule a pod onto the target worker node, where there is a each, if you have multiple nodes, it is going to decide so which is, node is available to take the request. So this scheduler is going to smart enough to decide the pod which is going to schedule on which target nodes. And kube control manager, again, it is one more component. It handles the various aspects of clusters control loop, like number of replicas, application, node controller. In the sense, whenever if you are trying to deploy an application which is of replication set, multiple replications, in the sense you are going to spin up an application for 10 servers, 10 pods. When I say 10 pods, it is going to maintain the, or it is going to control the 10 replica sets of the applications or the pods. Whenever if one pod goes down also, it is gonna bring up immediately the failed pod. So like that, it is gonna control the all the replica of your applications, and as well as a node controller. Suppose initially, if you have a two node installed to your cluster, if you are going to add one more node, target node, to your cluster, so this controller, controller manager is going to maintain all your nodes, and it is gonna handle the all the requests, all the parts it is going to schedule in such a way that, so etc is one of the one more important component. It is a kind of key value store of the cluster. It is storing all your cluster related information in the form of key value based kind of key value based in the form of that. um, and it acts like a it's a brain, it's a cluster brain, because it tells the scheduler. And 1 second, it's a typo. So it tells the scheduler and other process about which resources are available. uh, I mean to say, it is again interactive with the queue scheduler. Whenever a new, if you are going to create a new pod, so etcd is going to instruct the queue scheduler to go ahead and search any node is available. So go ahead and land that pod onto the respective target node. So that is the this component is going to do. And kubelet, again, as I said, kubelet is a one is an agent which is landed on the each node component or target nodes, and interacts with both the container runtime as well as the node. So container runtime, in the sense, it is again there is a one daemon set which is running on each uh, container, and it needs to communicate between the node, right? Because each node, the component, I mean the container is going to load on the pod, and again pod need load onto the any one of the node, right? So that's how this kubelet is going to communicate the containers as well as the nodes, in order to check the health, whether the any container is up and running, or if any container is going down, means it is gonna send information, pass on the information to the kubelet, to the controller, so that so and so pod is having some issue, go ahead and look into that. So like that it is gonna uh, pass on the messages to the cluster. Also it is responsible for starting the pod with a container inside. So each pod is having multiple containers as well. So how are you going to manage this pod status, if you are going to stop the pod, start the pod, and so all these operations gonna done through this kubelet only. And there is one more concept called kube proxy, which is again a node component responsible forwarding the request from service to the pods. So service is one more concept we will discuss in the next class. Services, and so proxy is a network component which is responsible for forwarding the request which is coming from the your APIs to the respective pods through the services. Because you don't have a direct access to pods, there should be some mechanism to forward your request to the pod, that is with the help of proxy. And it has intelligent logic, uh, and also it is going to decide the request to the respective. So if you are trying to connect some pods or containers, so the kube proxy is going to, it is smart enough um, uh, to land onto the respective containers. That is how it has some mechanism to connect the only the respective pod if you are connecting multiple pods, right? So that is how this kube proxy helps in landing your request to the respective pods and the worker nodes. Okay, so that's the components of uh, Kubernetes. So any questions so far in the architecture? If not,
Not no.
yeah, if not, we will uh, go to the hands-on part, so that we will get an idea. So we want minimum three servers. One is master node and two worker nodes, so that we are going to play some pod creations. How the pods, how are going to schedule on the target servers, target nodes. So we will get to know that. So installation part is doing very tough. Tough in the sense you have to pay more conscious. So these steps are straightforward. You already know that. So you can straight away select. And I wanted three. Um, Oh, it is choosing micro. For master, I'm going to choose medium because um, it need more capacity. So I'm just choosing um, T2 medium. I'm just spinning up only for master first. Then I will choose a lower capacity for nodes. So let it run the master. Let's go back. We'll spin up one more, two more. Cube node. Okay, let it be micro. I'm choosing last one. Okay, for the cube node worker nodes, I'm choosing number two numbers instances. Let me launch. So if you look at this one, so this is cube master, and these are the node one and node two. Um, so let's connect. First, I wanted to um, rename the servers with the help of hostname CTL. Okay, now it is cube master. So that it is easy to identify in the while deploying the pods. It is easier to identify which node is having which pod. Okay, and I wanted to run one script on each node. So for that, let me. I will share you all the scripts so that you will be easily going to do it. What this is going to do, it is going to update your binaries. It is going to install the Docker because Docker also is needed here, and going to create so many folders, downloading the things. So all these things are there. Instead of doing one by one, let's create one script and run it. So now, if you run, it is going to do all the actions in the background. So let it run in the background. Let's go to the node one. Cube node one. Okay, so this is the one. So let's run one more script on this. Okay, let's move on to the one more node. Cube node 2. Okay, we okay. So let's go back to master. So this is done. All the installation part of the Docker done. Now um, we need to run one more script. So here we need to add the master's private IP. Do you know why we are adding, you know, private IP instead of public IP in this script? I am using in the master only. I am using private IP, not the public IP. Do you know reason? Any? If you just come across with an AWS cloud. So what happens um, if you start and stop one AWS instance in the in the free trial or anywhere, if if you start it, it is gonna generate one public IP. If you stop the same instance again, if you start, it is going to allocate one more public IP. It is not giving the same public IP, but private IP is remains same. So that is the reason we should not use the public IP. But again, how are you going to maintain the public IP? In the real world applications, you have to go with the separate concept called elastic IP. If you look at this elastic IP, so this elastic IP is going to generate a static IP address which is going to use on the respective on the server. Again, that is pricing. It is gonna cost you something, some amount. So that is the reason. But in the if you are in the your account, if you are going to do some these sort of exercises for each and every restart, it is going to generate a separate public IP. So that is the reason. Okay, now I'm going to run a one command here on the master node only. Now so far whatever the script we ran, that's fine. Now no need to run anything on the uh, cluster, sorry, and then worker nodes. We have to do it in only in the master. Let me run one more command. Let's wait for some time. Okay, it is done. Cat cluster. So once you cat this one, it is gonna give you one command. So this is the one which is going to use. You are going to use this command to join your nodes. Okay. So before that, we have one more thing to set up, because we are maintaining a separate folder to keep all the um, Kubernetes related stuff in one folder. And you have to set up your network Calico plugin. Okay, now let's use this one to join the networks to here. So, so before adding, let's try kubectl get nodes. See, we have only one control plane node because we did not added any other nodes, right? So now let's add one. Run this. I'm just running this, joining the this thing on the each node, so that you are going to add this one. So this one, so this line we supposed to add additionally because this is the network interface, Calico network interface. Okay, one is added. If you run kubectl get nodes, see one is added, but still it is in not ready. It will take couple of seconds to add. So one more. Okay. So now two nodes added to cluster. kubectl get nodes. See, first one is ready now. Second one just now added. Still it is in recovery mode. So it is gonna add soon. Okay, already. So now our cluster setup is ready. Cluster setup is ready now. Let's check any parts is running or installed. So none of the parts are ready because we have not done any parts installation. So that is the reason no resource found. So now the lab setup is ready. We're able to get the nodes details. So let's deploy one uh, node, sorry, one pod. Give me a moment. Um, Okay, any questions so far in the installation part? Any doubts? Okay, one part I'm trying to install kubectl run, and name of the uh, pod is I'm taking copy open image http httpd httpd, web server. So now pod got created. So let's check whether how the pod is looks like. Kubectl get pod. See, hyphen w wide. So if you look at this, so we have created one pod name called Gopi, and the image name is httpd, and the pod is Gopi, and see, one out of one means one one container out of one is ready, and which is I running. And forget about this age is just now we have created. It had assigned one IP for this, and where it is running on the cube node one, because the scheduler is going to schedule the pods on the respective, or the where there is a least traffic is there, it is going to assign like this. Okay, so this is how it looks like, if you look at the pod on each node, target node, it looks like this. But if you install one more part, go p2, I'm running one more part, go p2, let's see where it is landing. See where it got run, it is landed on the cube cube node 2, because it is verifying the load of each target node, where there is a least traffic is there it is going to land like this. So cube node is very less traffic it has, and it is our latest pod got created on that. And initially it is creating the pod. If you look at once again, it is gonna start it. See, it is started now. Got it?
Yes.
Okay. How to delete a pod? Again, kubectl delete pod name gopi I'm giving. So pod got deleted. Kubectl get pod. So only one pod is running. It means, see how easily you are going to spin up your containers, remove the container, delete the container, or create in the container. It's so in a fraction of seconds. Just think in the real world, scenarios. If you wanted to build a one server for one applications, how long it is gonna take? It is taking minimum one day. You are spending time to create a server, adding all the necessary network things, storage things, creating the DNS. So it is a time consuming, and it has lot of manual process. But when it comes to the containerization, so see, in a fraction of second I'm going to create a pod, and I'm going to host on the web server. HTTPD is Apache server. We are going to host, and we are immediately going to terminate it. So maximum, I mean, the manual effort is going to minimize with the help of containerization. Hardly you are going to use the memory. How much? 1 MB, 2 MB. So you are going to uh, like if you compare the earlier days, for on one application you need to install, you need to spend a minimum lakhs together to spin up the one server. But here, after implementing containerization, you are just spending very less amount and very less resource it is consuming. So that is why containerization technology become a much more popular nowadays. Every each and every applications are there trying to migrate to the containerization now. So that is the advantages of containerization. And let me we'll go with one more use case. So I wanted to create a one Nginx server. Okay, how are you going to create one Nginx server? So let's create one YAML file. Um, Nginx. dot- So if you look at the syntax, this is how it looks like. API version kind is a pod because we are creating a pod, right? If you are creating a service, you have to mention service like this. Pod name is the image name is Nginx containers Nginx and image latest image and port is 80. So like that, just save it. There are multiple ways are there for creating the containers, but this is also one of the way you are going to maintain one YAML file and going to use the same customized content. So kubectl create -f nginx file. So this is the syntax. So pod got created, kubectl get pods. So now your nginx pod is ready. In just see for fraction of seconds, you are going to spin up your container. So this is a one pod. Nginx is a pod. In that pod, only one container I created. So I can create a multiple container also in a one pod. Okay. So how pod is loaded and which iPhone. Oh, wait. If you give like this, so this is Nginx is loaded on the cube node one in the target node, and on top of it we have created one pod. Again under the pod we have created only one container, that is Nginx container. Got it? No, so one in one pod you can create multiple containers also in the Kubernetes. So that is not possible in the Docker. So that is advantages. So we will go through the day by day in exercises. You will get to know how multi-container works in the Kubernetes. So that's how it looks like. Okay. And how to check the pod description. Kubectl describe pod nginx. So we wanted to know what is this nginx, what components. Let's use this describe pod so that you will get to know uh, what is this name of the uh, nginx is the name of the pod and namespace is the default. I will explain the namespaces after next class. And service account is default. Node cube node 1 and it has some private IPs, and this is the start time. Labels is nothing, we have not given any labels, that's why it is showing none. Annotation, so some this is some network related interfaces. Status is currently it is running. So this is the the IP of this container. IP only. Container ID, image, what is the image of this one? Image ID, what port it is used. 80 is the port, host name 0, host port. running state, and started. This is the this no when this pod got created. So that was it mean to say. So all this information you will get to know with the help of describe command. Okay, and here is the logs. So initially started the container nginx assign the some default. So this scheduler, as I said, no scheduler. The main purpose of the scheduler component is to schedule a pod on the respective target node. So which is the node that is cube node one. So like that, each component plays a important role, especially in the Kubernetes cluster. Pulling the image, because we have defined nginx 1.1, and that is then successfully pulled the image, create a nginx, started the nginx. So this is how it looks like when you describe the pod. And the same way, if you wanted to delete, you just use kubectl delete -f. The same file, if you give, it is gonna delete the respective pod. Okay. Okay, I will create a one multi-container node so that you will get an idea. Vi multicon dot OM. See here, I am providing the two containers. One is for Nginx and one is for Redis, so that you will get to know how to create a multi-containers also. kubectl, either if you issue create or apply also, you can issue -f. What is that? multicon.ml. If you issue like this, it is gonna create a container. kubectl get pods -o white. See, in GoP2 we had given only one container, that was some HTTP things. Now here we have created multicon pod. If you look at, two out of two is running. Two containers out of two also running. If anyone is not running, it is shows two out of one, like that. If any one of the container is gonna miss, but if two out of two also in running state, so you will get like this. It is landed on the cube node one. So that is how multi containers are going to load on the respective pod. So this is the same concept which it cannot work on the Docker plain normal Docker, because they don't have concept of multi container, right? So that is why Kubernetes become so popular in this, especially in the orchestrating the pods containers. So like this. And also it has a lot of advantages. So in one class, we cannot explain, because that you will get confused. But initially, first you do this lab setup and try to do these small exercises, so that you will get a clear understanding of um, basics of the how to create a prod, how to create a how to delete a pod, or like this. Okay. So we don't uh, do the complex. We cannot confuse you. So day by day we will go to different topics we have, like services, deployments, horizontal autoscaler. So many topics are there. So that is the reason I'm splitting this class into 2 3 classes. So let me mm, copy paste the things. So this one is, if you're practicing, this is going to change because it is going to change as per um, your setup. But this line is common. Last line, this is going to change. So make sure while practicing, but make sure this IP you need to change. The- So create a config on the master machine. Mention the master node private IP address. Okay, so I'm just highlighted here. Don't confuse with that, or else you cannot set up the cluster. And also I will copy paste couple of useful commands. Okay, or else I will get history. So that you just get an idea how to create. What is the command to list the pods, kubectl pods. Okay, I'll also mention one link so that you just go through that. See, it has some clear description. Kubectl get pod list all the pods namespaces. So I'll paste you this link. Okay, I'm just stopping because this is gonna charge again. My free tariff is completed. I'm just getting the uh, billing. So I'm just stopped. I did not terminate it. I just stopped so that we can reuse the same instances for tomorrow's classes. Any questions,
Okay.
Sunil, Shruti?
No, Gopi, we'll practice. We'll come to.
Yeah, yeah. These are practice based only.
Yeah.
You you have to practice. Otherwise, you don't get idea on how to execute a commands and all. Okay, let me start my screen share recording.